welcome back to free engineering tutorial on operating system. So in this video we are going to talk about demand paging and page fault. Okay, so let's start with demand paging. So at the time of execution of any program, we all know that there are some options which need not to be loaded inside the memory, okay, at that instant of time. So at certain instant of time, let's say page 1 is being executed by the process, then at that instant there is no need to access page number 449, okay. So at that time we can do demand paging and we can deploy this technique to eradicate or to get away with the need of loading whole memory at one instant or at the initiation of the program. So what will we do? So as the demand increases or as the demand is going on at the time of execution of the program, we will demand the pages or we will ask for the pages from the backing store. Okay, so let's say there is page 1 which is already there, so we will not demand it from the backing store. But if there is a need of page 2 which is not there in the physical memory, so what will we do? We will ask for that page with the backing store. Okay, and when we are getting that page from the backing store, so we have to deploy some page replacement algorithm. So there are some pages which are already present in this physical memory, okay. So we have to deploy some replacement algorithm to replace these pages with the incoming pages, okay. So these are the things which we are going to discuss in further videos, okay. So for time being, let's stick with the demand paging. So as demand paging, in demand paging, if the program A demands some data from the backing store, and then so for that instant it has to swap out some process and or some data in the backing store and has to swap in some data in the physical memory, okay. So now talking about basic concepts of virtual memory. So basic concepts of virtual memory is just simply valid invalid bit is being added to the page table, okay. So we have one page table, okay. In previous lesson we had studied about page table. So there are page numbers and frame numbers which are being entered in the page table, okay. So here what will we do is that we will add one extra bit to the page table whether the page demand is valid or invalid, okay. So what we are going to do is that, as you can see in this program or in this diagram, there is one additional bit which is valid invalid bit which is being added to the page table. So now I'm going to talk about what is page fault, okay. So at the time of execution, when the program needs a page and it is not getting that page in the physical memory, then there occurs a page fault, okay. So this page fault is handled by the operating system in these 6 steps. So what are these 6 steps is that, let's say this is the flow of the program going on in the virtual memory, okay, or in the CPU. Now it asks for a page by making one logical address with the page number, okay. Now this page number is not there, the corresponding frame is not there or it does not have access privileges. So for that there is one invalid bit, okay. So as you can see, if there is invalid bit, it will raise a trap, okay. So trap is just like an interrupt to the operating system. So it will show that there is a trap, there is some problem, okay. Now this problem should have to be handled by the operating system. So what is this error? That it does not have the pages which is being demanded by the process or program. So what will it do? It will raise a trap in the second step, and in the third step operating system will try to get rid of this trap. So how will it get rid? It will ask the backing store for the corresponding page, okay. So for the needing page, it will ask that page by the backing store. In response to that, backing store will give the page to the physical memory, okay. So in this step 4, backing store will fulfills the request or giving the response of the request of the operating system in the physical memory. Okay, so let's concentrate here. So if there are many pages or physical memory is already full, what will happen? It have to deploy some page replacement algorithm here to replace this page. Let's say this there is already one page, so what will it do? It will save this page in backing store and this page again to the physical memory. Okay, so swap out, okay, and this swap in. Okay, swap in. Now when this page is here in physical memory, what will it do? It will reset the page table and make this bit as valid bit. Okay, so now this page can be accessed by the program. So now as that all the things or demands are being fulfilled, now restart the instruction. Okay, so this thing is being fed to the logical memory or the process or the program. Okay, and the continuity of the execution is being carried out. Okay, so now as you can see that we have to calculate effective access time. Okay, so EAT, what is EAT? So it will be the average of all the page hits, means when the process is getting the demanded page, and all the page misses or page faults where the process has demanded and it is not being fulfilled immediately by the page table, okay, or the physical memory. So let's say there is a probability of page fault which is P. So P will be very close to 0. Okay, it will be very small. Now as you can see that all the 6 steps will take some time in this slide. As you can see that all the 6 steps are being held at that instant of time. The time will be calculated and will be stored in this page fault time. Okay, and this is the normal execution time of any page in the process execution. So what will it do? It will take the average of both the execution time and will give the answer as effective access time. Okay, so 1 minus probability means when the page hit has occurred or there is no page fault occurs. So for that it will execute normally. So the time will be normal execution time. And when the page fault occurs, so it will be multiplied by all the page fault time what it takes behind handling of the page fault. Okay, so these 3 things will occur behind the page fault. When the trap will be raised, then the reading of page is done, and then restarting the process. Okay, so in next video we are going to talk about page replacement. So be there in the next video. Thank you for this video.